Today's webinar will go over the importance of third-party controls. Now, I know I'm sure everyone here knows how many times we've done this kind of recording, showing the importance of third-party controls. However, today I just wanted to go over this again in much more detail, why third-party controls are important to use in a lab. Now, as we start off, first we must ask ourselves, well, what is a first-party control? We're discussing the importance of third-party controls, that's all right, but what is a first-party control? Now, a first-party control is any control material that has been produced by the instrument or the reagent manufacturer for the use on a specific test system or on a specific analyzer. Now, first-party controls are good in telling us whether the reagent and analyzer are working correctly. Sometimes they will mask some issues in the reagents and analyzers, but in general, well, yes, they can tell us whether the reagent and analyzer are working correctly or not. However, what first-party controls are not really useful in telling us is regarding clinical utility or outcome. Is the control covering all clinically relevant levels? Is the control also truly challenging the test system or not? Is the control commutable enough or not? All of those things, first-party controls, simply put it, they're not very good in telling us that. So from this, let's go and discuss the characteristics then of first-party controls. Now, first-party controls, in terms of their matrix, first-party controls are usually made using the same material as the calibrator is made from. They're also only designed by the instrument manufacturer for the use on their instruments only. So you can't use a first-party control from Roche on an Abbott machine, or you can't use a first-party control from Siemens on a Roche machine. In terms of the levels, the clinically relevant levels that they supply, well, they're not that clinically relevant. They're only supplied at 1 or 2 levels. And they also suffer from a lack of consolidation. Controls usually contain one or just a few analytes in them. They're not going to be as consolidated as some third-party controls can be. For example, our Clinical Chemistry Premium Plus control from Randox, Acusera, it has up to 100 analytes in it. Some first-party controls, they can't go anywhere near it. Regarding the stability, now first-party controls are not made to be stable for that long. Why? Because the instrument manufacturer wants you to use a new batch, a new lot of controls whenever they supply a new reagent lot. So you'll see with your customers as well, first-party controls are usually they usually are changing lots too often, because whenever a new reagent batch is released by the instrument manufacturer, whenever a new reagent lot is released, they will also come with new lot of controls. And target values on first-party controls are only assigned using only the manufacturer's reagents, only the manufacturer's calibrators and instruments. So they kind of lack the exorbitant peer group that a third-party control can provide. Now let's discuss why first-party controls, or dependent controls as they're also known as, why are they problematic? And then we'll go on and discuss how a true third-party control can be advantageous to a lab. So our first topic today, why are first-party controls problematic? Or basically the risks of first-party controls. Now, if I look at matrix of the material, that's the first thing. You know that first-party controls are made from the same material as the calibrator. They essentially act as a calibrator for the assay in question. That's the big issue with them. So let me show you some examples here. For example, here we have a graph that is showing caliber degradation on the x-axis, and then we're showing the value of the control on the y-axis. Here we have different controls. You can see the black line is a first-party QC, red line is a patient sample, and the orange line is the third-party control. Now, if there is a calibrator problem Let's say there's an issue with the calibrator on the instrument. It can often be masked by the first-party QC. Why? Because both products have the same issue. They are made from the same materials. Of course, that's going to be a big problem because if a problem exists with the calibrator, the same problem is also existing with the first-party QC. So in this graph, I'm trying to show you how the first-party control is not able to identify the problem in the calibrator. It's not able to identify the degradation in the calibrator. However, the patient sample and the third-party QC, both of them are decreasing because the calibrator, there is some calibrator issues due to calibrator degradation. Now, it's like obviously, if two things have the same problem, how will they know that they have a problem, right? It's like two guys sitting in a bar drinking beer till the end of life and thinking, oh, yeah, we don't have a problem. Who has a problem? Do you have a problem? No. So, yeah, if two things have the same problem, one can't identify the problem in another. So if there is a problem with the calibrator, it will be masked by the first-party QC as both products are suffering from the same issue, as they are made from the same materials. There is over-reliance on manufacturer specifications as well, because labs sometimes might assume that the first-party QC is validating the entire system. It's actually not. It's only validating to what the instrument manufacturer designed the calibrator and the first-party QC to test, then creating a blind spot for unexpected issues with the system and the calibrator not being recognized. Now, I have a case study here from a hospital in the Middle East that one of our sales staff actually saw. Now, this hospital in the Middle East had a high throughput of TSH tests. TSH is the thyroid stimulating hormone. It's there to diagnose hypo and hyperthyroidism. Now, they received a new lot of reagent, calibrator, and QC material to run on the machine. Now, after implementing the new lot of QC material, the first-party QC was always passing within the target ranges that this company provided to the customer. However, a few weeks later, what happened in this hospital in the Middle East was that they received a notice from the instrument manufacturer saying that the new calibrator and reagent lot had stability issues and they were degrading faster than expected. Well, did the first party control actually identify this problem? No, it did not. And because of that, the lab was really surprised. They were surprised as they had not picked this calibrator shift or calibration shift due to reagent degradation in their first-party QC provided by the instrument manufacturer at all. So they were obviously surprised in thinking that why did this not get picked up? So of course we asked them that, well, it's a first-party control, so you can see the reason why it's not picked up. First-party controls are not very good at identifying any problems with the reagent or the calibrator that's provided by the instrument manufacturer. So we recommended that they use our Immunoassay Premium Plus control for TSH. Remember, it also has ultra low levels of TSH to make to help diagnosis of hyperthyroidism possible. So our ultra low TSH values go all the way below 0.4. Anything below 0.4 is considered to be characteristic of hyperthyroidism. So we said that this is an advantage, by the way. You can use our third-party control and measure your full and check your full clinical range. And also, you'll be able to identify any issues. So they said, yes, okay, let's give it a try. And after using our third-party control, they could see that the QC results were low or outside the manufacturer's range for their reagent, while the first-party control did not alert this to the lab until the first-party controls manufacturer actually had to launch a notice. They had to give a field notice to the customer saying that there was a problem. So, of course, why wait for those notices to come up? Why not just identify the issue firsthand? And this particular customer, they were really happy with how our control performed. And of course, they've been using our control ever since. Now, without independent or third-party QC that are not tuned to the manufacturer's instruments, we don't make our third-party QC by thinking of a particular manufacturer in mind. Of course not. We make our third-party QC for any instrument. First-party QCs are only made for specific instruments. Our third-party controls, or any third-party control for that matter, is not designed for a specific instrument. It's not tuned to a specific instrument. So, of course, using first-party QCs can create a massive risk to those TSH patient samples and therefore the treatment of the doctor, because the doctor will take those results at face value and will then diagnose the patient and perform treatment or give treatment accordingly. So, of course, TSH, thyroidism, is a big problem in the Middle East. So this lab was actually really helped. This large hospital was really helped by the use of third-party controls. Because they had that problem with the first-party control, this lab in the Middle East, this hospital, had to test 2,000 TSH samples again because the reagent had an issue and they could not identify it when they were using their first-party control. It was only after the usage of third-party controls that they were able to identify it. It costed the lab about £15,000 to retest all of this. In man hours, in wasted reagents, in wasted calibrators, all of that costed the lab about £15,000 overall. So this is a very good example of how then a matrix, issues in calibrators, issues in reagents can then be identified by third-party controls better. And how, if there is an issue in the calibrator, the first-party control will not be able to identify the issue in that calibrator because they're made from the same material. Now, let's discuss another characteristic then, another disadvantage, I should say, of first-party controls, which is the levels that they're supplied at. Now, first-party controls are usually supplied in a bi-level format. There are limited levels provided by the instrument manufacturer, and this actually poses problems. An instrument manufacturer that comes to mind is Roche. Roche usually provides their controls in a bi-level format and not, even if the control has 4 or 3 clinically relevant levels, Roche will still provide a bi-level control. Now, a single level, first of all, can only check a very small part of the calibration curve. And therefore, even if the QC looks fine, there might be a problem with the method because you're not checking it at the full clinical range. You're not checking everything in the instrument and in the calibration. Now, 2 levels might be good to check a linear calibration curve. However, this is always the point that I'm trying to make with clinically relevant levels, that the number of QC levels should always depend on the clinical cutoffs for that analyte. If your analyte has 4 clinically relevant levels, well, guess what? You should use 4-level QC. If your analyte has 2 clinically relevant levels, you should use a 2-level QC. If your analyte has 3, then you should use a 3-level QC. Most multi-point calibrations often need a 3-level control to cover the full measurement range. And labs know this, but sometimes they still don't want to use the third-party control for different reasons. We always then should remind them what ISO then has to say about this, right? ISO is very clear in its statement in the new 15189 guidelines. It says that the IQC material should provide a clinically relevant challenge to the examination method, and it should have concentration levels at or near clinical decision limits. And when possible, should cover the measurement range of that method, of that examination method. When we say examination method, we mean the reagent, instrument, and calibrator. All of that falls under the examination method. Now, our controls, the third-party controls that we sell in Randox, they have analytes at key decision levels so that you can ensure accurate instrument performance. But not only that, we also help increase the lab's efficiency by removing the need for the lab to purchase additional low and high levels at an extra expense. Our Immunoassay Premium Plus QC is a good example of this, where we provide ultra low levels of ferritin and B12, suitable then for anemia monitoring. From our competitor, who is a third-party competitor, you need a separate anemia control. Now I'll show you an example here for cholesterol. The first-party control is just good at identifying limited, I would say, levels, or they're not actually measuring the full clinical range of the control here. Right? The graph here portrays the standard calibrations of a cholesterol assay, where the yellow markers indicate the standard detection of a first-party control. Again, where the analyzer feels comfortable testing to. That's what the control is actually checking for. Whereas if we look at the third-party control, it's actually measuring the full clinical range as well as taking into account all the clinically relevant levels. Measuring the upper and lower levels of detection as well as the normal level. Now, as an example, we can look at coagulation controls. Now, these controls, the coagulation controls, let's see, in a coagulation lab, they were running PT, prothrombin time, PT INR tests. The instrument uses the reagents and the QC from the instrument manufacturer. Now, what happened in this lab was there was a small misalignment in the instrument's probe assembly, which causes slightly longer clotting times for actual patient samples. So their PT times were higher than what they should be. Now, the first-party control, which is formulated to clot within a very specific narrow range, it's not going to go over that range, is basically showing everything's fine. Because these longer clotting times are not being identified by the first-party control. The QC is basically compensating or is less sensitive to this mechanical error, and this is something that we should always kind of talk about. This is a part of checking clinically relevant ranges. Now, the instrument handles the QC really well. The QC and instrument are in cahoots. They are each other's best friends, so they won't want, best friends don't like to actually identify problems in each other. But if you had a true best friend, of course, they'll tell you what's wrong with you. Similarly, third-party QC is the true best friend here of the instrument. They will not compensate or be less sensitive to what the instrument has wrong with it. Now, the third-party or independent QC, it is differently formulated. It is not made to pass the instrument. It is not made for a specific instrument so that it can pass every time. Well, if you kind of think about it, is my blood made only for Roche instruments? Is my patient sample only made for Roche instruments? Are any of our colleagues, Barry, Colin, Depeche, are their bloods only made for Roche or Abbott instruments? Of course not. Their blood can be tested on any instrument, and therefore the third-party control should be tested, can be tested on any instrument as well. So if our patient samples are not made, if Colin or Depeche or Barry's patient sample is not made for a specific machine, why should a control be made like that? That's the whole point. And these third-party controls also come with more clinically relevant levels that could have spotlighted this mechanical issue immediately in this coagulation lab. Now let's look at some real-world examples from first-party QC. I'm sure you've seen this example quite a lot of times before, but I'll mention it still. Now in Vietnam, this is a case study from our sales staff in Vietnam. This hospital was running 2 different machines for HDL cholesterol testing, and they were using the same method, and they achieved the same means when compared using their peer group in their local EQA. However, they were using only first-party controls on both systems. Now, because of the new guidelines, ISO guidelines that came out, they wanted to gain ISO 15189 accreditation. So they purchased a lot of Acusera controls to be tested on both systems. Now, following the use of this control, of our HDL cholesterols, our lipid controls basically, they saw a bias that was occurring on system B, a negative bias that was found on system B. So they then obviously contacted the instrument manufacturer and said that, well, this bias appears whenever we use a third-party control. The instrument manufacturer said, well, when you were using our first party control, did this bias come up? And the customer said no. Well, then the instrument manufacturer said, of course, it's a problem with the third party control, said the instrument manufacturer. They didn't take blame at all. We always like to pass on blame. That's just the human condition sometimes. So the instrument manufacturer said it's an issue with the Akisera control. Nothing is wrong with us, with our machine. Well, then the customer came back to us and asked, well, what's the problem with your control? The instrument manufacturer is saying it's a problem with your control. So we decided to then investigate by looking at our RICS data for this. So we looked at our RICS data globally for instrument B for HDL cholesterol. There was no bias coming at all. However, when we looked at the instruments in Vietnam for System B, we saw that there was a negative 12% bias locally compared to the global peer group in our RICS program. So we saw this significant change, and we then contacted the instrument manufacturer telling them that, look, you were saying it's our fault. We've just checked not only this hospital's instrument, but there are about 13 other instruments in Vietnam that have this 12% negative bias on average. So you better go and look at them. So of course the instrument manufacturer got really worried. So they sent out technicians to check all these instruments. So it wasn't just an issue in this Vietnamese hospital. It could have been an issue for System B in the whole country of Vietnam. And when they sent their technicians out, indeed, System B had a problem with it. System B's incubation chamber had unstable temperature fluctuations, which was seen across all analyzer models in Vietnam. This was then identified for System B as a localized Vietnamese issue for that manufacturer. So yeah, well, don't mess with Akisera is what the moral of this story is. The instrument manufacturer should have understood that third-party controls obviously will be able to identify instrument errors because the instrument manufacturer knows that their first-party control will mask any issues, right? So we were able to prove it to them. This is a very good example of why the correct third-party control is vital to use. Now, if we look at another example, now this is a case report. This was actually published in 2014. Now, in 2014, what happened was this report was actually published in 2015, but in 2014, Abbott had to recall. They published an urgent field notice regarding a product recall for their Abbott PTH, parathyroid hormone reagent. This parathyroid hormone reagent had some issues with it, and Abbott explained why they recalled it. They said that there was a performance shift in the Architect PTH assay that had the potential to then generate falsely elevated results on patient samples. So this PTH reagent had a positive, basically shift on it, a positive bias. Now, Abbott said that results generated from this reagent demonstrated a positive shift relative to those generated from previous reagent and calibrator lots. The issue also impacted Architect intact PTH reference ranges. Now, the Abbott Architect PTH controls did not identify this shift. They couldn't detect this shift. All reagent control and calibrator inventory were impacted. Of course, the control did not identify the shift because the control and calibrator are made from the same material. And those materials, those controls are then made to mask any issues in the reagent or the instrument. So everything here you can see, reagent, calibrator, control, inventory, all of them were impacted. And that then led to about 40,000 inaccurate results being released in the Lombardy region of Italy. This case study comes from Italy. Now, the Lombardy region of Italy has about 10 million people in it. Imagine if the same thing happened in London, Greater London and London, or like the biggest part of London you can think of, right? It could have been much worse. If the same problem happened in New Delhi, in Tokyo, or in Hong Kong, the impact could have been much worse than just this. Now, the paper itself, also, if you need a copy of this paper, please Teams me or email me, and I'll be able to send you a copy of this paper to show to your customers. Because the paper, it's in the paper, it says, quote, probably Abbott Laboratory customers had performed their IQC using exclusively proprietary Abbott PTH controls. Otherwise, this result variability could have been prevented by using third-party materials. So the paper itself mentions this. Now, these are misconceptions. Some instrument manufacturers, and it's not just Abbott and Roche. I'm not just singling them out. There are other instrument manufacturers, all instrument manufacturers are there. They try to push their own first-party controls on customers. Why do they do this? They basically tell the customer, they sell convenience to the customer by doing this, because they say, don't worry, you can get this complete all-inclusive testing packages. And who doesn't love all-inclusive testing packages? I mean, I'm sure there are many guys out there that love their 3-in-1 shampoo, conditioner, and body wash. But just like that shampoo, conditioner, body wash 3-in-1 solution will not help your scalp or your skin, the first-party control will not benefit the customer. It will not deliver unbiased performance assessment. It will essentially act as a calibrator in question for the test in question, because it's made from the same materials as well. So why are these conceptions pushed on to the customer, to your customers? Well, it could be because instrument manufacturers are trying to hide some issues with their analyzers. Is that the case? I'm just asking questions. And customers are being blindsided into believing that first and third party controls are created equal. They're clearly not. Now, we discussed then the risks of dependent controls, the problems that first-party controls have. Now, let's go and discuss how a true third-party control can be advantageous to a lab. How do we discuss this? Of course, we're going to look at the characteristics of true third-party controls in this section now. Now, third-party controls, the matrix used in third-party controls is either going to be human-based in the case of Acusera, or it's going to be 100% human serum to perfectly mimic the patient sample. We will provide clinically relevant levels to ensure that critically important concentrations are checked on the instrument. Now, of course, third-party controls like Acusera controls, which is a true third-party control, it's not semi-dependent, it's completely independent. You can run our controls on any manufacturer's instrument. They are highly consolidated. Some of our controls can contain up to 100 different analytes in a single vial. The target values will be assigned for multiple different instruments using multiple methods and reagents. And of course, our control actually provides long-term stability to then be able to monitor lot-to-lot variation in reagents. And this is something that labs are very interested in knowing. Now first, let's then discuss for Acusera our commutability and matrix composition. Now, commutability refers to how a material, a QC material to be specific, reacts to the test, reacts to the assay and to the method being employed to measure and analyte. If the QC reacts to the testing system in the same way or in a similar way as a patient sample would react to the testing system, then we can say that that control is highly commutable. This is the question that we must ask ourselves. Does the IQC react to the reagent, to the calibrator, to the instrument in the same way as a patient sample reacts? Of course, this is now an ISO guideline as well, because this relates to a very important point. If we are performing tests on patient samples, then our QC should challenge the testing system in the same manner as a patient sample challenges the testing system. If an IQC matrix is not commutable, then is it truly challenging our testing system? And are you confident in the results that your patients have received? How can you be confident if the control is not commutable? If the control, especially for immunoassay and immunology, if it is made from bovine material or equine material, that's not going to be really commutable, because bovine and equine material, they have different ranges of concentrations. The matrix is completely different from a human matrix. It will not react to the test, to the immunoassay or immunology test that you're doing in the same way as a patient sample would react. Will the QC accurately show any shifts or trends occurring on the analyzer? Again, that's highly doubtful. And let me show you how you can quantify commutability. How can we look at commutability in the form of a number? So here we have the example. Now we have creatinine. This is a creatinine reagent from that we've measured the bias, the percentage bias, from 2 different lots of creatinine. Now what we are seeing here, if we look at manufacturer 1, no surprises in which third-party control competitor this is. I'll let you have a guess. And yes, it's right. Now, if we look at controls for manufacturer 1, they are not reacting like a patient sample, because you can see the patient bias, the patient mean bias is 2.6%. You can see the biases for the manufacturer 1. It's not the same. It's not even close. This is how we can quantify commutability, because we can say that from 2 different lots of this creatinine reagent, the patient sample is reacting in this manner. Is the control reacting in the same manner? Are we getting the same numbers? No. So we can confidently say that this control is not reacting like a patient sample, because the changes in values is not the same from one lot to another. If we look at manufacturer 2, now this is a first-party control. It's not detecting any bias at all. It's saying reagent 1 and reagent 2 for creatinine, like reagent lot 1 and reagent lot 2 for the same reagent for creatinine from the same manufacturer is the same. They have no variation in them. But we know that lot-to-lot variation will always exist between reagents. So of course, this first-party control is not giving us the perfect picture. Now, if we look at the Randox control, you can see it's behaving in the very similar way as a patient sample behaves to the testing system. Now, ISO says that the IQC material should react to the examination method in a manner as close as possible to patient samples. Right? We manufacture our immunoassay and immunology controls from 100% human material, making them highly commutable. Therefore, they react to the testing system in a manner as close as possible to patient samples. We also don't use any preservatives or stabilizers in our immunoassay controls, because we don't want that to affect the commutability of our sample. Now, there are studies that have been done on commutability of QC. And if you want, I can send you these studies. You can ask me. You can see these 2 studies have been released in the last 3 years, 2022 and 2023. Then let's look at lot-to-lot variation and stability. Now, ISO says that you should be using an IQC that allows, the IQC procedure allows for the detection of either lot-to-lot reagent or calibration or calibrator variation. To enable this, ISO also gives you a guideline. To enable this, ISO says the lab procedure should avoid lot changes in IQC material on the same day or on the same run as either lot-to-lot reagent or calibrator change. So you should not be changing your reagent lots at the same time as you change your QC lots. Keep the same QC lot so that when you change your reagent lots from one lot to another, you can see variation in the reagent lot. This is very important to know, because if there is lots of variation in the reagent lot, that means your patient sample results will be wrong. Of course, they can have a significant bias on them. And this was actually studied in this German study. Now, I do have the English version of this German study as well, so don't worry. I can give you the English version as well. But this study that was published in 2019 studied this. And you can see here we are checking for lot-to-lot variation in sodium for a sodium reagent. And you can clearly see when the lot was changed, the patient sample, the patient mean changed as well. The independent QC changed as well. However, these two first-party controls did not change at all. They're not showing any variation. They're saying reagent lot 1 and reagent lot 2 for this test are the same. Of course they aren't. Now, in the UK, we had a particular hospital that was using active vitamin B12 from the instrument manufacturer. And the instrument manufacturer provided them with basically 9 different lots in one single year. So of course, Barry and Depeche and our UK team would not have this. So they offered a better solution. With Accusera, they didn't have to change the lot 9 times. They only changed it twice in the year, allowing them to then check for lot-to-lot variation between one lot to another of their active B12 reagent. Now, let's look at concentration levels and then accurate target values. Of course, for a third-party control, this is going to be very important. Usually, controls are provided at various different concentration levels. However, I always say that don't think that every control needs 3 levels, and don't think that every control only needs 3 levels. Some controls might require more than 3 levels, and some controls might require less than 3 levels. It just completely depends on the clinical relevance of those levels. And that's why our third-party controls are really useful. Because if we are providing it, think about this, if we are providing test results, patient sample test results, within a specific range to the doctor, we are saying that this test result is within this range. How do we know that this range is reliable? Have we run QC with that range? Have we run QC with a range that is clinically relevant? Now, the concentration levels within the controls should be relevant to the concentration at which doctors make diagnostic decisions and treatment decisions. That's the simple point. I'm sure everyone can, even if every customer can wrap their heads around this. That yes, if we are reporting a particular patient result at a particular range, we should be running QC at that range to make sure that our analyzer is giving us correct results. And this is again mentioned by ISO as well. The ISO guidelines also mention this in ISO 15189 2022, section 7.3.7.2. Now, I'll just give you an example of our immunoassay Premium Plus control for ferritin and B12. Now, if we look at vitamin B12, the range, the ultra low level for vitamin B12 should be below 190 picomoles per liter, should be below 190. If you look at our control on different instruments, you can look at our immunoassay Premium Plus control for total vitamin B12 values on the Architect instrument. You can see that then on the Beckman instrument, on the Simmons, and also on the Roche instrument, they're all going below 190. If we look at our biggest competitor, and you know who they are, you can see that they're not touching 190 even. Why? Because they're selling a separate anemia control, and also why? Because they are not able to stabilize their consolidated immunoassay plus control, their LifoCheck immunoassay plus control. I know I'm not that subtle, am I? Their immunoassay plus control, they cannot stabilize it to that ultra low level for ferritin and B12. So there are two reasons. They're selling a separate control, and they're also not able to achieve what we have been able to achieve with our immunoassay Premium Plus control. Now, ferritin, you can see again for ferritin, it should be around 20. And all of the machines that we've tested this control on, these big four, Abbott, Roche, Beckman, and Siemens, all of them are reaching that level. That's the whole point. That's the question I ask you again. Have we used QC that is clinically relevant? Have we used QC levels that are clinically relevant? And if we haven't, we cannot be confident that our test system is accurately and precisely measuring the analytes within accurately and precisely measuring the analyte within that clinically relevant concentration range for that test. So these are some very important points. Your clinical relevance, lot-to-lot variation, stability should be long enough to basically measure lot-to-lot variation across reagents. Now, I gave you the example of active vitamin B12. Our stability, we have a long shelf life for it. And that is why we are able to measure lot-to-lot variation between reagents for our B12 control. So it's clinical relevance, the ability to measure lot-to-lot variation between reagents by having long stability and shelf life, and also the matrix of the material. The commutability of our third-party controls are better. Now, finally, I'll talk about more of a cost point of view, from a cost point of view and from an efficiency point of view, why third-party controls are also good. Because we'll talk about instrument usage now. Now, labs should be looking at all of these different aspects while they select the quality control most suitable for their lab. They should look at consolidation, clinically relevant ranges, open vial stability, the matrix and the raw materials that are used to make that third-party control, the pack size, the dead volumes, and also then instrument usage. This is more of a first and third-party control point, this last point here. Now, from instrument manufacturers, for example, if we have a Roche control, that now can only be used on a Roche instrument. A Roche IQC can only be used on a Roche instrument. Of course, you're not able to use the Roche QC on all of these different instruments. Of course not, because they're not made for these instruments. Roche also says it's only made for the Roche machine. What about third-party controls? That's not obviously the case, because third-party Acusera controls, for example, they can be used on all the different kinds of machines. Not just these four, I'm just using these four as an example, but any analyzer for that matter. And not only is this an advantage of third-party controls, but also if you look at first-party controls, for example, serology QC, now you'll see that we have from first party, there were about 30 vials of QC that you needed from Roche. However, from Acusera, how many do you need? 4. So again, another advantage of third-party controls is that they are highly consolidated. So consolidation becomes that extra point that I wanted to discuss, that extra cost effectiveness and efficiency point. Consolidation is also very important to then look at, because these 4 vials will now reduce the storage space requirements that this lab needs. It will also then reduce the costs, overall costs. Consolidation will always help. So from a cost point of view, from a space and preparation, man hours spent putting the controls on the machine, from all of those points of view, a third-party control, and obviously a third-party control such as Acusera, is going to be vital for any customer, for any of our potential customers and existing customers. So just to kind of sum all of this up towards the end now, ISO highly recommends the use of third-party controls. Why do they do this? Because they know that third-party controls give unbiased performance assessment of analyzers. It's basically a third party coming, that's why they're called third parties, right? That's why they're called third-party controls. It's basically a neutral person coming in and checking whether your instrument is working or not. If you have a first party control and if they're checking the instrument, whether that's working or not, of course not. There is some conflict of interest there. Third party controls, they have unbiased performance assessment. They correctly identify issues with instruments. Any trends, shifts, calibration problems, reagent issues will be identified correctly. And of course, third-party controls can be used on a wide range of different chemistry and immunoassay instruments. Now, a study in the US, this was now done in the US, a study conducted in the US stated, it was conducted by the CDC, the Center for Disease Control, and it said that labs which used third-party controls had an average error rate of 29% lower than the labs not using third-party controls. Now, they also found that using QC material different than the test controls provided by the kit manufacturer decreased the error rate in MPEP performance surveys. Now, what does MPEP stands for? MPEP stands for Model Performance Evaluation Program, which basically the CDC uses to assess the performance of labs that test for recognized diseases, such as HIV. So we can see that using third-party controls helps in improving lab performance. But why is that the case? Well, we've discussed why that is the case in this whole presentation so far. So I hope you've been paying attention, and I hope my point is resonating with you. Also, from a UK quality manager of a lab in Northern Ireland, you can see here it says, the lab manager says, as an ISO 15189 accredited lab, it is part of our material selection procedure to use controls sourced from a third party, as use of control materials from the same manufacturer as the test reagents can mask underlying issues due to commutability of the material. Now, I encourage you to read the full quote and maybe share this quote with your customers if you need to. Moving on, it also says if the manufacturer's test kit is drifting to the associated QC, will then display the same drift. So if the reagent is showing a drift, the QC will show the same drift and mask that issue. This can obviously impact patient results as well as EQA performance for that lab. So that's an additional point that this quality manager brings in. They say that, of course, it's not just about patient results, it's also about the reputation of our lab in EQA schemes. Our EQA performance is also then not that good because EQA samples are basically like third-party controls. They can be tested on any analyzer. So, of course, the EQA results also get impacted by this. Now, there are other guidelines around the world, such as the National Association of Testing Authorities in Australia, CLSI in America, and of course, then we have RILIBAC in Germany. All of them are mentioning are advocating the use of third-party controls. So finally, these are the advantages then of third-party controls, just bringing them up again. Long-term monitoring of QC due to prolonged shelf life is possible. Our controls create a true challenge to the testing system, and money can be saved by using one single third-party control on different instruments because our product is a multi-analyzer product. This allows the laboratories to buy fewer controls and waste fewer controls, which then overall helps increasing the efficiency and obviously the productivity of the lab. Now, many labs I've seen, the people working in those labs, these healthcare providers, take their job very seriously. And I've seen some of them are really in this field because they care about making their city, their place, a better place regarding healthcare, in terms of healthcare, helping their patients. They are there for their civil service. Now, for those people, if you find that you have such customers in your region, always try to then appeal to their moral side as well by telling them that, yeah, using the first party control is not doing you any favors. And if you want, I can also help you bring that message across through any type of help I can give you through webinars, through traveling to your region, or maybe through training you. In any way I can help, I will help to bring this message across from my end as well. Now, with that, thank you so much for listening to me. Thank you so much for attending. I'll see you in another webinar.